And there we are. Okay. What we see is a number line. Okay? And we have points A and B on the number line. How far apart are A and B? How far apart are A and B? 8 points. They are, come on. Yeah, that's dead. All right. They are 8 away from each other. Now, Corwin, how did you figure that out?
It's 3 away from -3 and 0, then 5 away from 0 and 5.
Oh, great job, Corwin. All right, Corwin says it's 3 away from 0 here and 5 away from 0 here, and 3 and 5 make 8. Okay? Corwin actually used what is called absolute values to figure this out. And we'll talk about absolute values later. Now, is that the only way to figure it out? What's another way to figure this out? How far apart 3 and 5 are, -3 and 5 are. What's another way to figure out how far they are apart? What do you think, Aubrey? What could you do? You can count 1, 2, 3, 4, 5, 6, 7, 8. Okay? You could, backwards 1, 2, 3, 4, 5, 6, 7, 8. Okay? You can do it that way. There's another way of figuring it out. What's another way of figuring it out? Using math. Using difference is, what is the magic word with difference? Starts with an S. Subtraction. Could you use subtraction? 5 minus a -3. Minus a negative is plus a positive. Okay, 5 minus a -3 is 8. So that warms you up a little bit for a little bit of math. Okay. In this class, there's lots of vocabulary terms that we need to learn. So we have vocabulary sheets to fill out. And you think, oh, vocabulary. Yeah, just wait till you hit biology class. And Mrs. Underbrunner, you'll have all kinds of vocabulary to do there. And you think, Mr. Bierstock, he's so mean. I bet Mr. Wheeldryer wouldn't make us do vocabulary. No, Miss Wheeldryer actually makes you do more vocabulary than Mr. Bierstock does. So, I have vocabulary sheets. We will take vocabulary quizzes in here. Our first vocabulary quiz will be after the first 4 sections. Now, I am nice. If you keep your vocab sheet the entire chapter and have all the words down on it, then the day of the first chapter test, you can hand that in and get extra credit. So do not lose this vocab sheet because it's worth extra credit on your first test. So, what we have is point, line, plane. Those are the first basic terms in geometry. Okay? What is a point? Okay, come on. Oh, I got to go like this. I'm not used to using my finger to run this. All right. A point is a location and has no size. So, on your vocab sheet, you would write a location and has no size. The next one, a line. An infinite number of points on a straight path that extends in 2 opposite directions with no end and has no thickness. And a plane. And then I'll talk about these a little bit more after you get done writing them down. Okay, so a point, we use a dot to represent it. It's just a speck in the universe is a point. Just one tiny little speck. A line goes between 2 points and it goes on forever in each direction. Okay? So in here, we'll look at lines on floor tiles, lines on ceiling tiles, and that type of thing. A plane is a flat surface that goes on forever. So it's like a wall. It's 2 dimensions, like a wall or the floor or the ceiling. Now, when 2 lines meet, they form a point. When 2 planes meet, they form a line. Okay? So the intersection of 2 lines is a point. The intersection of 2 planes is a line. All right. Then we have segment rays and opposite rays. We got lots of vocab today. First day, lots and lots and lots of vocab. All right. So if a line goes on forever in both directions, a segment is part of a line with an endpoint at each end of it. Okay? It stops. Lines go on forever, segments stop. So most of the times when we talk about a line in here, we're actually talking about a line segment. Okay? A ray has one endpoint and goes through another point and goes on forever. Okay, so basically a ray is part of a line with one endpoint. So a segment is part of a line with 2 endpoints. A ray is part of a line with 1 endpoint. Now opposite rays is a ray going this way and a ray going this way, and they share the same endpoint, and 2 opposite rays actually form a line. An angle is formed by two rays with the same endpoint. Each ray is the side of the angle, and the common endpoint is called the vertex of the angle. So a vertex, gotta know what that is. The vertex of an angle. Okay, for angles, it's really, really important that you know how to name them. The vertex is always the biggest part of the name. So if you use three letters to name an angle, the vertex has to be the middle letter. So the middle letter is the vertex. So this angle can be called RQP or it can be called PQR. Since there's only one angle here, since there's only one angle at this point, okay, we can just use the letter Q, or if there's a number on the inside of it, we can use the number 2. But if there's two angles there, we can't just call it angle Q. Because actually, how many angles are right here? Not 2, 3 angles. Okay? There is RQP, there is PQS, and then there's RQS. So there's 3 angles there. So we can't just call it angle Q. Okay? We have to use the appropriate letters. Okay? But if this isn't here, now we can call that angle Q. Okay? Because there's only one angle, so there can only be one angle there for Q. All right. The ruler postulate isn't super important. It just says that we can actually measure lengths with a ruler because we can assign values to certain points. Okay? So, what we talked about at the start of class is distance of a line. How far is it? And Corwin used absolute values, which we have here. Okay? But one of the other, I forget who came up with, you can use subtraction. Okay? So we use subtraction here. 7 minus 3 is 4, or 3 minus 7 is 4. 3 minus 7 is actually negative 4, but we use absolute values. Because distance is always positive. Because how far is it from here to Sioux Falls? Like 45 miles, right? How far is it from Sioux Falls to here? 45 miles. It's not a negative 45 miles. It's 45 miles. There's never negatives on distance signs. So a negative we can't have for distance. So it's always positive. That's why we use absolute values. Okay, so we're talking about a postulate. The ruler postulate allows us to figure out distances. A postulate is a statement that's assumed to be true. Okay? Geometry was invented by this guy by the name of Euclid. He wrote a book called The Elements. I didn't get it ready yet.
But
hey, are you proud of us? We remembered.
You
I set an
remember.
alarm and everything. It just
All
went off.
right. All
Good
right.
morning, everyone. You say hi, Peter?
I did.
Just say hi, everyone.
I
All right, here we go.
All right, over to Mr. Greenbach. You feed the fish.
All right. So as you see, we have a fish tank in here. And sometime during class, on Tuesdays, somebody will come down and feed the fish. You guys do not feed the fish ever. Do not lift up the cover and put anything in the fish tank. You can look at the fish. You can say hi to the fish. You can talk to the fish. But do not lift the cover and put anything in the fish tank. Do not feed the fish because we don't want them getting too fat. Or the worst part is we don't want the tank to get all icky from extra food sitting on the bottom like we did last year. Okay. All right. So how long's KL here, sir?
12 to 16.
Yeah, how long is it? How far is it from 12 to 16?
4.
4. Absolutely. It is 4. Now, how do you figure that out? Well, you can take 16 minus 12 is 4. You can count from 12 to 16, 1, 2, 3, 4. You could take 12 minus 16 and take the absolute value of that. Okay? So, I bet we won't go to where we need to go. We'll see if it does it. Segment addition postulate. All right. So I have a link that's supposed to actually go to where it's supposed to go, but looks like that link didn't actually work great. Boom. Dismiss. Oh, come on. All right, we won't worry about that. The segment addition postulate says this. We take segment JK and segment KL and add them together to be segment JL. Okay? If they're all part of the same segment and there's not an angle going on, if they're part of the same segment, we can have two segments together to make a whole segment. So if we're told that this segment from G to H is 16 long, we can figure out what X is and figure out how long FG is and then what FH is. Okay? As long as the points are all collinear. Collinear means that they are on the same line because the base word of collinear is line. So they are on the same line. So, in this class, we're going to be doing lots and lots and lots of algebra. Okay? Lots of algebra here. So, if I say that GH is 16 and I see GH is 2x plus 2, we simply write out the equation 2x plus 2 equals 16. Okay, we got to solve this equation. What's the first step of solving this equation, Reese? What? Divide? You could, and we could get there by dividing, but normally we wouldn't divide first. Okay, I don't think Mr. Hodgen taught you that. I don't remember your name. What's your name? Elizabeth. Okay, Elizabeth, what's the first thing we do?
Subtract 2 from both sides.
Subtract 2. I would subtract 2 first. All right, so if we subtract 2, we get 2x equals 14. And then we do what Reese wanted to do. Then we divide by 2.
Elizabeth Kelsey and Olivia Braskamp, please come to the office.
And then x equals 7. So if x equals 7, what's 3 times 7? 21 minus 1 is? That part is 20. This part is 16. Using the segment addition postulate as the boss, how long is it from F to H? Thanks, Addison Boss. It is 36. We got a bunch of Addisons in here. Wow. All right. So let me get back to here. All right. Now you guys do this on your own. Do this on your own. KM is 67, so this whole thing is 67. This and this somehow have to add up to 67. Now, you know what? Instead of doing it on your own, let's do it this way. Do it as a table. I will get you markers in a second. Oh, look at that. Between the two of you. And we're going to leave these on our tables. I'll get you markers here. And we'll leave the markers on the tables as well. Yeah, you can do it then. Whoop, I meant to give you one. Do it on as a table. Figure out how you'd go about this.
So now we know this. So 5 times x 40 minus 12. 40 minus 12. 38, around 28.
Work together. Talk about this. Yes, Corwin. I don't have any out yet. I will have them out at some point, but I don't have them out yet. Yes. You already got it. Okay.
Did you understand that? Why did you add? Oops.
We don't know. Oh, wait. No. If it's 89, then minus 12, which is 67. Oh, wait, we need to get a plus 67.
I guess they didn't want me.
But I don't think we did it in the right way, because I don't think our math is.
All right, James. Did you and Radley come up with an answer yet? No? All right. Who else? Kenzie, did you come up with an answer yet? Kenzie and Elliot? 28. How many got 28? 28 was the answer. So you should have gotten 28 somehow. Okay. So how do we get to 28? Well, KM is all of this, right? So we have to take this and this. It's a segment addition postulate. So what we do is we add these two together to equal 67. So 4x and 5x make 9x. 7 minus 12 is a negative 5 equals 67. So to get rid of our negative 5, we have to do the opposite. We have to add 5. So 9x equals 72. Divide by 9. X equals 8. But 8 is not our answer. That is not what they said. They didn't say, what is X? They said, what is LM? So you take this 8 and plug it in for the X of LM. 5 times 8 minus 12. Or 40 minus 12, which is 28. Okay? A little bit of algebra flashback. A little bit of Hodgins room flashback for a lot of you here. Okay, some of you had Cradivell for algebra. But yeah, that's working with the segment addition postulate. Now the protractor postulate says, okay, we can assign values to angles. Okay, so angle ABC. Okay, this angle right here. We go from 0 up to 60. So angle ABC is a 60-degree angle. Is angle DBC also 60 degrees since it goes through 60? And the answer is no. Because D, if we see where the 0 is, it's on the inside track, not the outside track. Here, 0 is on the outside track, so you use the outside track to figure out the angle. Here, 0 is on the inside track, so we use the inside track. So looking at this, angle DBC is 120 degrees. So we want to figure out what angle BEC is. Angle BEC. Now they're not very nice. C is at 105, going on the outside track. C is at 105. But this is like 47, I would say. So you'd have to take 105 and 47, and would you add, subtract, multiply, or divide? Subtract. You'd subtract those to get 58. It's a 58-degree angle. How many degrees would you say CED is? How many degrees is CED? 130 and 105. What would you get, Cannon? If you took 130 minus 105. 25, exactly. That's a 25-degree angle. Okay, angle addition postulate. We add up angles. I'm going to skip over that. Here we go. If SPR is 60 and SPQ is 120, what's QPR? If SPR is 60, SPQ is 120, what is QPR? Oh, I haven't picked on Braylon off to all stable yet. So, Braylon, what do you think it is? 60? Exactly, because we subtract, okay? Because this angle plus this angle has to add up to 120. So if the whole thing's 120, we subtract. 120 minus 60 is that. Okay, so congruent segments. What are congruent segments? They are the same length. So in geometry here, we make tick marks to say, well, AB is the same as CD. If you have two tick marks, PQ would be the same as RS. RS is not the same as CD because this has two tick marks, this has one tick mark. So if they have different tick marks, they're not the same. If they have the same tick marks, they're the same. Angle marks, they have the same angle marks. They're congruent. That means they're the same size. They have two, they're the same size. Okay? All right. Some of the properties. And we'll talk about these more when we get to proofs, but they introduce them now on day one. The reflexive property is if you have the same exact thing on each side of the equal sign. Okay? It's like reflection in the mirror. This is the same as this. If you flip things on opposite sides of the equal signs or congruent signs, if you flip them around, that's the symmetric property. Okay? Flipping them around. And the transitive property says if the first is congruent to the second and the second is congruent to the third, then the first and the third must be congruent to each other. Because if this is equal to 4 and 4 is equal to this, then these two are both equal to 4, so then they must be equal to each other type of thing. So those are reflexive, symmetric, and transitive property. Okay. So looking at tick marks, if this is 32 degrees, how big is this? 32 degrees. Okay, 32 degrees because they have the same tick marks. Okay, all right. So if that's 32 degrees, and they say that YWV, or they say that XWZ is 127, this whole thing is 127. What is left for that middle? How much is left for the middle? 127 minus what? 127 minus 64. And you get 63. You get 63. Okay, that is it for today. So, what I'm going to do, I'm going to end my video.